So thanks everyone for coming to this talk. As he just said, my name is Ethan Rogers. I'm a staff software engineer at Armory, co-lead of the Kubernetes SIG, and I've been working on Spinnaker for the last 3 years. And a lot of what I've worked on the last 3 years is related to this area. So it's something I'm super passionate about and wanted to share with everyone kind of what I've found that helps kind of make Spinnaker fit your organization. So it's kind of a short agenda today. There will be a live demo, so if you pray to the demo gods, please send one up for me. We'll talk a little bit about background and like why extensibility is important, and then we'll talk a little bit about the implementation, specifically around run job and webhook, and how you can use that. So let's talk a little bit about background. When you talk about extensibility and you start asking the question, what is extensibility? It's specifically within the context of Spinnaker. Most off-the-shelf products, it's like a one-size-fits-most, right? So I don't think anyone in this room has ever been able to pull some software off the shelf and it fit exactly their use case 100% of the time. And so when you start talking about adoption of software, whether it be Spinnaker, Kubernetes, Jenkins, whatever you want to kind of say, it's how can I make it fit the requirements and the constraints that I have and the rest of my organization has. Most of the time that's implemented as like a plugin, right? So Jenkins has plugins. You can plug functionality into systems to provide this kind of custom workflow or custom code that you actually need to run. And it really comes in a lot of forms. The most easily adoptable one is webhooks. So most systems today, like GitHub, they provide you like an external way to trigger some internal system. This might be webhooks or some scripting or some native extension, like the plugins work that we're currently doing for Spinnaker. But the most important thing to realize is that needs vary. And if you are building a software platform for maybe internal consumers or external consumers, you want to provide options. Not everyone needs as deep integrations as some other platforms provide. So you want to be able to satisfy the needs of users, non-power users and power users alike. So let's talk about examples. I mentioned Jenkins already, but Kubernetes. Kubernetes is probably one of the most platformable products on the market today. And they have so many different ways to do extensions. You have CRDs, admission controllers, mutating webhooks. Operators usually kind of plays into a lot of these things and gives you a way to extend. Drone CI provides plugins as Docker containers. So you can write whatever your extension is that you need, package it as a Docker container in whatever runtime that you need. So that's also another really popular way of extending. We talked about this a little bit already, but just to kind of dive into it farther, why do we need extensibility? Specifically around the area of software delivery and even farther, continuous integration. So software delivery is where the rubber meets the road. I've been talking about this with a lot of people lately. If you look at software delivery and continuous integration as two distinct things, continuous integration is kind of where the lowest amount of risk is. If your build fails, if your test fails, you're not really affecting anybody who's paying you. You're affecting people that you pay because they're trying to work on those systems, but the people who are using the systems and getting value from them are not affected. Software delivery, continuous deployment, on the other hand, if you have a bad deployment, a lot of people are going to know. So being able to extend your tools to help you have better deployments is really critical. Spinnaker is a platform, right? A lot of people that I talk to use Spinnaker as a single pane of glass, right? They want it to be the hub in the spoke of all of the other tools that they use. And Spinnaker provides this safety around deployments. But a term that I hear a lot, right? We have deployments, but what about releases? I think deployments are you take a single binary and put it in a single environment. But as we progress and we reach more scale and we have more environments, we start having to think about how do we release software across those environments. Netflix is talking a lot about managed delivery, and that's really kind of the idea that they're playing into, is how do we orchestrate this delivery across all of these different environments. And so we can think about that as releases. Everyone's got different workflows, so stateful applications, external testing systems, artifact promotion, checks and balances. All of these are needs, custom needs generally, that organizations have when they start thinking about software releasing and software deployments. One of the interesting things too about Spinnaker is that what you see in open source is actually just the tip of the iceberg. I don't see any Netflix folks here, but I was sitting in a meeting a few weeks ago and somebody made the point that Spinnaker isn't not sticky at Netflix just because of the deployments. It's sticky at Netflix because of all of the different systems that it integrates. And we were talking about that just a minute ago. We want Spinnaker to be the hub at the center of this universe of tools that we have. And that's really where the extensibility and power of Spinnaker comes into play, because we can start to make it that for our companies. So what are our requirements for extension, right? And I think it's really simple. It should be easy to use. Right? If we are a company that wants to do some extension, but we don't want to be writing custom Java code or integrating with Deck, the UI, we need it to be easy and easy to consume out of the box. We also want to be able to push data in and pull data out. What I mean by this is our pipelines have rich information. And the work we need to do, the extensions that we need to be able to act on this information somehow. But it also needs to be able to tell us, what did we do? What did we transform? What artifacts did we push into something? Or what did we do as part of this stage, so that other extensions or native Spinnaker stages can take advantage of that information. So to me, those are the kind of the three key things that we need to think about when we think about extension. So when companies usually go down this route, a stage is the first thing that comes to mind. It's the thing that we use every single day. We're building pipelines with stages, and it really fits this kind of model that all of us as software engineers fit into. So that's kind of where I'm going to focus on in this talk. We're going to talk a lot about stages and how we can build stages that extend our workflows. So let's talk about making it your own. I said at the title of this slide that we're going to talk about webhooks and run job. Show of hands, how many of you are using webhook stages in your pipelines? Okay. What about the run job stage? If you're using Kubernetes, you probably do. How about, I'm going to talk about this in a second. What about pre-configured webhooks or pre-configured run jobs? Okay, awesome. That's great. Well, I hope you guys get something from this today. So we'll talk about webhook stages first. They are, in my mind, the simplest form of extension, right? Everyone in this room has probably written a curl request at some point, or called some API with a webhook or an HTTP call. What it lets us do is call out to an API during pipeline execution, and this is probably the simplest way to integrate with external systems. Everything today is an API. If you don't have an API, your software is probably not getting used. And so Spinnaker being able to interact in this way is actually super valuable. Some use cases I've seen with Armory customers and people that I work with in the community, kicking off integration tests on custom systems. ServiceNow is a huge one in kind of the larger organizations that I've worked with. And obviously we don't have a native integration, so we use the Webhook stage to support that. Some kind of brief details. We support any HTTP method. You can send a payload. One of the really cool things that we can do is wait until the thing is complete. So if you fire off a request, we'll pull an endpoint that you specify, and you can actually have this kind of long-running stage. And it works really simply. So you make a post to kick off a thing to your integration service, and that thing returns JSON. It's a pretty simple thing to understand, but it's a really powerful thing that we can use. So here's a screenshot. I don't know how easy that is to see in the back, but yeah, you can specify your URL, your method, any statuses that should fail the stage fast in a payload. You can use the expression language in that payload. So again, you can pull data out of the pipeline and send it off into your extension. So to kind of like tie it back to the kind of requirements that we defined, it's easy to use, right? We said this already. Most people in software engineering have made an HTTP call at one point. You can integrate with all of your APIs. Pushing data in, do it via payload, pull data out. The response body from your webhook call gets injected into the pipeline. Pretty simple. So what about jobs? You've probably heard me talk about this or read a blog post that I've written on this or seen a PR that I've submitted. Just let's talk about jobs generally. There's this concept of batch jobs, right? If you have written software or you are responsible for operating software, you've got what I like to call persistent workloads and then non-persistent workloads or batch jobs. And they're used to perform like bursty chunks of work, and they run frequently but not continually. They have a lifespan. They start, they do some work, and then they die. One of the interesting and unique things I think about batch jobs is they're usually written in whatever language you want, especially with Docker being so pronounced in the industry. You just package your runtime in your software, and then you execute that Docker container. They're triggered by some external event, be a cron, a webhook, an event queue, maybe new data is available. Batch jobs have historically been used to process data. It's a way that we can do data transformations. And they're parameterized. So you may have a batch job that takes some set of arguments, and depending on that set of arguments, changes, does something different. Does it sound like CI? Because that's really what we've been doing with CI for the last 10 years. So we kind of had, these conversations internally in Armory this year where we saw a lot of different products coming on the scene where running a container was just like par for the course, right? If you had a platform that integrated with Kubernetes, running a container to do some type of work was what users were looking for as a way of extending. So previously to the work that we did this year, the Kubernetes v1 provider had a run job stage, the Titus provider had a run job stage, but it just never was implemented for Kubernetes v2. Show of hands, who here is using the v2 provider for Kubernetes? Okay, so roughly half the room. So that's what we set out to do. We set out to kind of fulfill that interface and meet that need. And that's what I will be showing in the demo. And the cool thing about it is it's accessible. It doesn't matter what language your developers or what language you write in. If you can run a Docker container and you can put some code in a Docker container, you can use this feature. Again, we want to be able to see state as it's happening. So one of the requirements that we had for this feature was being able to view the logs directly in the UI. So that's a feature that it has. It also, you can consume data. So you can pass data in via command line arguments or environment variables, and then use that downstream. So this is roughly what it looks like. So for Kubernetes, at least, it's different for Titus and Cloud Foundry, but you have cluster A, B, and C. You might run a Kubernetes job on the middle cluster, and it actually will echo back out Spinnaker properties that you can inject into your pipeline. One of the benefits of this type of model is that the jobs that you run directly alongside your applications. So in my demo, you'll see me run a set of integration tests that I'm running directly beside the application that I've just deployed. So that keeps you from having to like put your applications on like a public internet or actually expose it maybe when you don't want to. Again, how does it fit? How are we tying all this together? It's easy to use, right? If you're already deploying to Kubernetes, you probably already know how to write a job. If you're already using containers, you probably already understand this concept. Again, push data in via environment variables and command line arguments, and pulling data out. So something to note, it is interesting, is that each provider kind of implements this a bit differently. Kubernetes is via logs or artifacts. So with Kubernetes, if I echo Spinnaker property with a key, we'll parse that. If I echo some JSON, we'll parse that and pull it into the context. As I understand it, Titus puts like files out to S3 and it's fetched. So it's just kind of, the idea is we want to pull data out. How it's implemented is varies between provider. So building on top of that, this concept of pre-configured jobs and webhooks kind of comes into play. And this is where I think the power of these two stages and these two features really kicks into gear when we talk about extensibility. So pre-configured jobs and webhooks are a way for us to provide native feeling stages. The users are not actually defining these things themselves, they're consuming them. But you don't have to write custom code in Spinnaker. You don't have to maintain a custom build. You don't have to redeploy Spinnaker every time. Well, you do have to redeploy it every time, but you don't have to build Spinnaker and go through the whole process. You just change some configuration. All of that configuration is in Orca, and so it's YAML and very familiar. But what we're trying to do is create these like reusable and dry stages that capture the common things that users are doing within our organizations and bringing them into Spinnaker as first-class citizens. So we want to encapsulate that complexity, things that users are doing over and over and over, or maybe have requested, and bring that into the system. Really bad, I did not realize that this would show up so small, but when I talk about dry and I talk about reusable components, over here on the left is a job for building a Docker image. I'm actually going to demo this. But you can see it's like, I don't know, 50 or 60 lines of YAML. And that's really complex. And for users who need to use this every day, they may not understand that complexity. They may not even want to deal with that complexity. But as a pre-configured job over there on the right, I've got 4 options and 4 parameters that I need to pass in as a user to get all of the value provided by the stage on the left. So that's really where that comes into play. So a demo, and we've got a demo, but I'll actually show you guys how some of this stuff is configured. So this project, let me just pull the README up right here. Where am I? Okay. Anyway, so this project is available at GitHub. And if you want to go to Ethan F. Rogers Summit 2019 demo, what I essentially did was I wrote a small little web application in Go. It's got a Docker image. It's got some unit and integration tests. And all of the YAML for the stages that I'm going to demo here is also stored in the repository. So if you find that you want any of these custom run job stages and you want to use them, go into the repo and start pulling them out. But let's look at the pipeline real quick, and then we'll look at how they're implemented. So the pipeline I have is actually what I would consider a fairly common deployment pipeline. I'm doing some things in here that some people do, some people don't do, but it's something that I've seen. So the first step that I've got is this build Docker image stage. You will probably remember the Canico stage that I just showed up here. If you're not familiar with Canico, it's a Docker image builder that can run without a privileged security context. So you're not having to do the Docker and Docker stuff. You can just run it, and it's secure. But what I'm doing is I'm actually building a Docker image from my repository in Spinnaker. The next thing I'll do is I'll kind of jump back into a native Spinnaker stage and deploy it to our staging environment. Let me just pull up the configuration here. That'll be better. I'll deploy it into a staging environment. Here, if you're familiar with Kubernetes, the V2 provider, this should all look pretty familiar. The Kubernetes manifest that I am deploying, that for some, speak of the devil, is stored in that Git repository as well, so we're going to pull it from there. Then I'm going to run a set of integration tests, so I also have another pre-configured job that will run a user-defined script against whatever container image they want, and that script is stored in a Git repository. This is actually something that a lot of users ask for. We've had like a Jenkins run script stage in the past. I'm not really sure what the state of that is today. The other way of doing this today is to run a Jenkins job that checks out your repository. So this is kind of a Kubernetes native way of running a script as part of your pipeline. Next, again, I'll just deploy into a production namespace in the same cluster. And then one thing that I hear a lot is, how do I automate adding things to Jira or kicking off workflows? So what I wanted to demonstrate with this pre-configured webhook was, how do we make an API request to Jira to maybe mark a ticket as deployed? My goal was to make another stage that pulled a Jira ticket out of a commit, but I ran out of time. So I'm just going to statically define that one for now, and hopefully it gets the point across. So let's take a look at how some of these stages are implemented. And they will probably look a bit complex, but the whole goal of the pre-configured run job stage or pre-configured webhook stage is that you only have to deal with that complexity once instead of having all your users deal with it every single day. So these are all stored underneath here under this jobs directory. Let's look at the Canico build image stage. So this is kind of the anatomy, and maybe I can make that bigger. For anybody in the back, can you read that? Ish. What if I go one more? Perfect. Thank you. Okay, so this is kind of the anatomy of a pre-configured run job. There is documentation for all of this online on the Spinnaker website. So if you forget a parameter or something, you can go find out what it is. We've got labels. So a label would correspond to what the name of the stage is in the UI. Description is pretty obvious. It will tell you what the stage is actually meant to do. One of the really, really awesome things that I love is this parameter section. So this tells you the parameter. So here we've got 4: branch, repo, Docker file, and destination. You define a mapping. So you can define how the user's value maps to the Kubernetes job that you are running. In this case, what I've done is I've actually mapped it to environment variables that are getting passed into the various containers that are running. So for instance, I'm going to map the repo to the first environment variable of the init container, the branch to the first one, the repo to the second one. The Docker file will then go to a different container, and the destination. So if we look at how those are mapped, also, actually I'll touch on this. The Kubernetes jobs are defined in line, so they're part of the configuration, seated under this manifest key. So it's just a Kubernetes job manifest. We actually generate a unique ID that we append to the end of the name to avoid collision. So you can actually run this same job in number of times and not have jobs kind of killing each other or Kubernetes complaining, oh, a job with that name already exists. So that's just something that we noticed happen. Obviously, you can specify your labels, but the way this is implemented is using an init container and then a container. So this is kind of a little trick that I picked up. I don't know how common this is, but what I'm essentially doing is using an init container to set up my environment. So in this case, I'm using the new Git repo artifact type that we added for customize, taking advantage of that in this 1.17 environment. And I'm using it to actually grab the project that I want. So the branch will be user specified, the URL will be user specified based on those mappings. And then I've got a couple other configurability environment variables here. I also mount a shared volume. So it's the init container clones into one repository, and then the main container works against the code in that repository. And then my container, which will run and then exit, which is what a job should do, is running the Canico image. So I did not write this image. I simply pulled the image off the shelf to run it. But I mapped the user supplied variables of Docker file and context into environment variables so it runs. So what this stage's goal is to take the Docker file in my repository, build an image, and push it to my Docker registry, which is not something that Spinnaker can do out of the box today. I think it can if you use Roscoe, but it's a bit different than what most people want to do. So the other stage that we have is the run script stage, which uses the same kind of practices, except we do a slight variation. So again, we have repo and branch to capture that information from the user. But we also have, we also let the user specify the image that they want to run their script in, so they can define their runtime. But then they also specify the command. So in our case, in our pipeline, the command is supply this endpoint and run this integration.sh script, which I will, nope. Integration.sh just takes an endpoint and runs a set of Go tests against, like makes some HTTP calls. So it's actually pretty simple, but really powerful. And then finally, if we want to look at the Jira update webhook stage, can I show this one? Yes, I can. This is just the webhook stage, so it has a lot of the same parameters, so label, name, description, all of that good stuff. You can specify your authorization headers in there as well, and then a payload. We also have parameters too. How you map them is slightly different. So just be aware of that. Also, we have documentation. But we define an environment, and then we, in this case, call the, what is the API? Where's the URL? Oh, and your Jira URL. There's the actual API for updating that. So, but yeah, that's really simple. And now all of these things show up as stages in Spinnaker. Let's jump back to the pipeline here. If we want to add a stage, we can search for Canico, and I know now that I can build Docker images, or I can say Jira mark something as deployed. What is it? Run a script, right? I can select a stage and it does that. It shows up. Now, let's talk about trade-offs for a second, though. You'll notice that this is all very simple. The UI for doing this is the same across both. I just have a set of string parameters. If you need something more complex, you want to have this like richer feel, you actually have to start writing custom code and extending all of these components. So it's kind of it's a question you need to ask is like, what do I need to get more value of? Is it this having this rich, off the shelf, I use Spinnaker every day and it feels perfect experience? Or is having the ability to do some of these things in your pipeline more valuable, more worth it than having that? So just something to be aware of. So let's actually kick this pipeline off and see how it works. Perfect. All right, so let's go ahead and start this pipeline run and see how some of these stages in action. So the Docker image building stage is getting kicked off. We can see here in the UI, I can zoom in one more. I know it's not perfect, but the UI is going to get really funky if I keep going. But we can see all of the user supplied information. So we know I'm going to pull from the master branch. I'm going to run against the repo for this demo, the Docker file that I want to build against, and the image that I want to push. Again, like I stated earlier, we can see the UI, the logs in the UI, so we don't have to jump into Kubernetes just to see logs. And so, yeah, so you can actually see this thing happening. That stage is now done, so we're going to go ahead and deploy. We can see, obviously, the YAML that was deployed. Now we're going to run our integration tests. Again, I supply an endpoint. This is a Kubernetes service name, so Summit 2019 demo in the Ethan Dev namespace. That also ran. We can see the logs there. So I install my dependencies and run my tests. And then we deploy to production, and then mark deployed. So let's go check Jira. Did that actually work? Yep, we've got a deployed production name label. So the whole kind of goal of all of this stuff is like, how do you automate the workflows that are specific to your organization without having to invest super heavily, right? If you went to my colleague's plugin talk earlier, you know that there's kind of an initiative to give you that really rich experience without having to keep custom builds going. But I think a lot of times that you don't actually need that deep integration. You can get by with running jobs and webhooks to automate your processes. So with that, some resources that you can go see. I've written a lot about this topic, so there are a couple blog posts that you can see. We've got some user stories One of my friends, Miles, who's actually presenting right now, did a really cool guest spot. We've got docs for the custom webhook stages and custom job stages if you want to go check those out. And these slides will be available online as well. So I don't have a thank you slide, but thank you.
Thank you, Ethan. Just wanted to open the floor for questions. I want to ask, what kind of questions do you guys have?
So, taking your idea of running jobs a step further, if you need to provide like secrets or credentials to any of those jobs, what's your preferred approach to that?
Yeah, so I guess it depends on like what the rest of your organization is doing, right? So if you're, specifically for Kubernetes, if you have like a method of supplying secrets to your applications, I would suggest doing something similar to that. Because you can mask a lot of the complexity in a pre-configured job, you have kind of the freedom to put whatever init containers or sidecars you want in there to supply those secrets. But yeah, it's just doing something similar to what you're already doing with your workloads is what you could do. Or you could just leave them directly in the config and take that risk.
Okay, thanks.
No problem.